In the late 60s, programming wasn't a job you went into to make life exciting. It was a total snooze. Tons of assembly and filled with losers from like finance and accounting. And if banking was boring, then telecom industry was straight up comatose. Back in the day, that thing with the Flintstone disc, you had to speak to the operator so that she can find your line. Boring. That is until Alan Kay came on the scene at Xerox PARC. You might not know who he is, but he changed your life more than Elon Musk's iPhone and YouTube put together. You see, Alan didn't know it yet, but he changed history with his one simple idea. According to him, everything is an object. He introduced ideas like windows, overlapping GUIs, and direct manipulation of objects on the screen. He even presented the first ever IDE. Boring old programming took over the world. And then 50 years later, in 2025, we're still paying the price. Critical infrastructure, airplanes, hospitals, banks, they all carry systemic mistake, like the 2008 crisis. Sold as innovation, but it entrenched complexity, fragility, and tech debt that society still suffers from. And everybody was just happy to ride along. Nobody saw an issue with that.
Our OOP code practices are strong.
But there were some who saw it coming. When Alan Kay gave his presentation, they heard something entirely different, and they anticipated the change. One of the places that needed the most innovation was, and still is, telecom. In the 60s, neighborhood had a single part line that connected households. They could even listen to each other's conversations. Those lines connected to the switches that used humans to route your calls. Telecom infrastructure was extremely expensive to build and maintain. Any failure meant millions lost due to downtime. The 80s saw the regulation of telecom markets. Multiple vendors were racing to provide faster, more scalable and efficient systems. Survival meant being the first. There was one small Swedish company that by the start of 1997 will take over almost half of the world's mobile market. They also changed the world when this was released.
The Sony Walkman is a tiny stereo cassette player with truly incredible sound.
And they invented Bluetooth you use every day. The company had a hunch on how to disrupt markets. So now its goal was to conquer US telecom market. They had to innovate. Again. At that time, OOP was king. All the drivers, switches, custom embedded code was written in C, and it was praised for the speed and efficiency. But there was a minor problem with it. Projects couldn't afford the delays caused by debugging memory leaks, crashes, or long development cycles. OOP now stood in the way of innovation, and just being a better programmer wasn't the answer. So, the new language was needed that can satisfy all of those. Let me decode it for my younger viewers. Surprise, none of the languages could do that, so it wasn't possible to satisfy all of them using existing languages. Focus was to have an elegant, small language with built-in concurrency.
Programs in such languages are considerably shorter than the equivalent programs in imperative languages. Here, for example, is a program in C. And here is the equivalent program in Erlang.
The view that the processes were part of the language rather than the operating system wasn't popular. Thanks to OOP, It still isn't. First real battle test was done at Ericsson Business Communications. The team wanted to prototype a new software called ACS, and they needed a new programming language. 2 years after, results were in. The report compared the effort in man-hours of development in Erlang compared to others. The report showed that Erlang reduced implementation time by 3 to 25 times. The average increase in productivity was a factor of 8. At the time, people disliked the idea that the effect could be due to having a better programming language, preferring to believe that it was due to some smart programmer effect. First, most significant event for Erlang was AXN.
Ericsson was one of the very first suppliers to concentrate on this new technology in its computer-controlled telephone exchanges.
It was a project aimed at developing a new generation of switched products, ultimately to replace the outdated X10 system developed in C++. This new project was to be the largest ever Erlang project so far, with over 60 programmers. This number was viewed as inadequate to support the needs of a large development project. To save thousands of hours of work, they built a product unit called OTP. It was a set of libraries and the descriptions of the Erlang way of doing things. It contained libraries of Erlang code, documentation, courses, how-tos, design patterns for building common applications. These design patterns are the result of many years of experience in building fault-tolerant systems. In 1998, Ericsson AXD301 large-scale industrial software project was announced. It's also highly reliable and runs in real time. Code changes in the system had to be performed without stopping the system. The software for the system was programmed using the behaviors from the OTP libraries. All of this was programmed by a team of 60 programmers within 2-year time span. Same language helps support 50 billion messages every day with only 32 engineers. But I'm getting ahead of myself. The XD301 was a spectacular success. It had 6 times less code than its C analogs. Furthermore, the project had an absurd 9 nines reliability, and the development process had a 4-fold increase in productivity. Just when they thought everything was going so well, in 1998, Erlang was banned within Ericsson. This ban was the second most significant event in the history of Erlang. It was the main reason why Erlang started spreading outside Ericsson. The reason given for the ban was as follows: save you some time, in simple terms, we're lazy, it's hard to maintain, we don't want to innovate anymore. Eventually, approval to release it as an open source license was obtained in the same year. Shortly after, the majority of the original development team resigned from Ericsson and started a new company. In retrospect, the Erlang ban stimulated the long-term growth of the Erlang. Erlang has successfully rerouted itself outside of Ericsson. It quickly spread outside of Sweden. In the UK, there is Erlang Consulting, which hires out consultants to the industry. In France, Procession makes web stress testing equipment and instant messaging solutions. In South Africa, Erlang Financial Systems makes banking software. All these external developments were spontaneous. Interested users had discovered Erlang, installed the open source release, and started programming. You might have heard about the small company, such as MasterCard. It's shipping financial switches implemented in Erlang, and they are far from being alone. Other areas where it's used actively include private and public blockchain, payment, credit card gateways, banking APIs. The investment banking giant Goldman Sachs used Erlang in a part of its hedge fund trading platform. What about massively multi-user online gaming? Nintendo Switch has sold over 130 million consoles. The system uses an Erlang-based messaging system to handle millions of concurrent connections. Other popular gaming companies, such as Riot Games, they use Erlang too. League of Legends has up to 130 concurrent players at a time, with an Erlang messaging system allowing them to chat simultaneously without interruptions. MasterCard, Discord, Pepsi, Toyota, Facebook, Apple, Supabase, French government, Heroku, Remote, Change, Adobe, PagerDuty, Financial Times, and list goes on and on. If it would be such a cutting-edge tech, Wouldn't everybody talk about it like it was TypeScript, Rust, or Golang? First, talking about stuff and solving problems is two different things. Elixir is maintained by open source community, and they don't have neither the budget nor interest to spend excessive time to market themselves. Second, the language requires you to solve problems differently. You can't expect to be as performant immediately as in OOP, since it requires you to forget what you know and lean into the new functional paradigm. Third, most of the programmers don't question themselves with concurrency. They don't need similar scale as nationwide telecom system. So, not everybody can come up with a problem that requires same level of scalability that Facebook does. But I encourage you to give it a try. Elixir consistently took high positions over the years on being favorite. Aside from learning new way of thinking, you will have fun. Some of the best problems you can solve with it are crisscross game, guess the number, math puzzles. Or if you're brave, start with the concurrency straight away. Build your own email web server, build your website, create simple chat application. I'll post a link to a couple of the resources in the description and maybe create a link later on to one of the projects to showcase how to start. Thanks for watching and keep up the great work.
Push the goddamn button! Push the goddamn button! You heard what she said.